Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. Friends, in this video lecture we are going to focus on how to find the half range Fourier series. So there are two types of half range Fourier series. First type is called as half range cosine series, and second type is called as half range sine series. So this is cosine series and this is sine series. So now in this video lecture, our focus is on half range cosine series. We are preparing one more video where we are discussing this second case, half range sine series. In this video lecture, we are going to only discuss the examples which are related to this first case. Now friends, whenever half range sine and cosine series is there, so then value of interval is 0 to L. So this is very important. So please remember that for this half range series, length of interval is from 0 to L. So now to understand the first concept, half range sine series, we have prepared this video. Now let's take the first example. So first example is find half range cosine series. So this word is important. So find half range cosine series for the function f of x is equal to x in bracket pi minus x in the interval 0 to pi. So this is the first example. So this example is very straightforward. Question is given, find half range cosine series. Whenever half range cosine series question is there, so now definition for half range cosine series is in the interval 0 to L is f of x is equal to a naught by 2 plus summation a n cos of n by x upon L. Let's call this as equation number 1. So to find out the Fourier series means what? Find out the Fourier coefficient a naught and a n. So after getting the value of a naught and a n, put this value in this equation, we get the required Fourier series expansion. Now friends, to find out the Fourier series coefficient, so let's try for the first coefficient. So here the value of first coefficient is a naught, and which is defined as 2 upon L integration 0 to L, then this is f of x dx. We can write this as 2 upon, but here what is the value of L? So now here for the half range sine as well as for cosine series, length of interval is from 0 to L. So if we compare the given interval, so value of given interval is 0 to pi. If we compare with the half range cosine series interval, then we get the value of L is equal to pi. So this is the way to calculate the value of L. Now put L is equal to pi, we get this as 2 upon pi integration 0 to pi, then value of f of x. Value of f of x is x into, this is pi minus x into dx. Now for our simplicity, let's simplify this integral term. We can write this as 2 upon pi integration 0 to pi, then this is pi x minus x square into dx. Now after simplifying this term, our next aim is to find out the integration of this term. This is very simple, so we can easily apply the formula. Integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1. So we apply this formula and we get this as 2 upon pi, then integration is, this is pi which is constant, integration of x is x square by 2 minus integration of x square is x cube by 3 and its limit is 0 to pi. This is very simple. We just apply this rule for integration. Then after applying this rule, let's put the value of upper and lower limit. When we put the value of upper limit, write down one bracket, so to avoid the confusion in the sign. Now upper limit is pi, so we can write this as pi into, this is pi square by 2, so we write this as pi cube by 2 minus, this is pi cube by 3, then minus lower limit, if we put x is equal to 0, this is 0, minus again x is equal to 0, this is equal to 0. Now just simplify this, we get this as 2 upon pi, then if we take denominator common, 3 2s are 6, then we get this as 3 pi cube minus 2 pi cube, so we get this as pi cube, and finally we will reach to the answer, this is pi square upon 3. So this is the value of first coefficient, which is called as a naught. So value of a naught is pi square by 3. So this is our first coefficient. So now let's find out the value of second coefficient, which is a n. So but for our further substitution, I will write the value of a naught, which is pi square by 3 here. So this value will be helpful for us for the further substitution. Now, after finding the value of first coefficient, our aim is to find out the value of second coefficient. And we know the value of second coefficient, which is denoted by an. So now let's first define an with the formula an is equal to this much. So we can write the value of an is equal to 2 upon L integration 0 to L, then this is f of x cos of n pi x upon L into dx. Now after writing this formula, our aim is to put the value of L and f of x. We know the value of L, which is pi, so we can write this as 2 upon pi integration 0 to pi, because L is pi. Then value of f of x is, this is x into pi minus x into cos of n pi x upon, put the value of L, which is pi, so we can write this as pi into dx. So this pi term will get cancelled, and we can write this as 2 upon pi integration 0 to pi. So for our simplicity, let's take this multiplication. We can write this as pi x minus x square into cos of nx dx. This pi will get cancelled. Now to find out the integration of product of two term, we know that generalized rule for integration by parts is applicable. We say that first function integration of second minus derivative of first integration of second plus second derivative third integration, and so on. So this is the generalized rule for integration by parts, which is very much helpful for us to find out the integration of product of two term. So now let's call this as the value of u and call this as the value of v. So we choose the u whose derivative vanishes after finite number of steps. Now after applying the general rule for integration by parts, we get this as, so u as it is, so we can write this as pi x minus x square as it is into v1. v1 means integration of v, that means integration of cos term. Then we know the value of integration of cos, which is sine, so we can write this as sine of nx upon derivative of this nx with respect to x is n. First function integration of second. Now minus sign, then u dash, that means derivative of this term. So derivative of this term is pi minus 2x. This is pi minus 2x. Then again v2 means integration of v1, that means integration of this term. So integration of sine, so formula is given here. So integration of sine is minus cos. We can write this as minus cos of nx upon derivative of nx is n, so n into n, we get this as n square. Then next is plus sign, so u double dash, that means take the derivative of this function. So while taking derivative of this function, don't consider this minus sign. So this minus is because of the generalized rule for integration by parts. So now derivative of this function, so derivative of this function is minus 2. So pi is constant, derivative of minus 2x is minus 2. Then again take the integration of this term. So integration of cos, we know that integration of cos is sine, so we keep this minus sign as it is, into sine of nx upon derivative of nx is n, so n into n square, we get this as n cube. Next derivative is 0, that's why we come up to this step with the limit 0 to pi. So in this way we can easily apply the concept which is called as generalized rule for integration by parts. So after applying the generalized rule for integration by parts, now friends, our next aim is to put the value of upper limit and to put the value of lower limit. Whenever we put the value of upper limit and lower limit, concentrate on sign term, because sign term is always 0. Now here upper limit is pi, so if we put x is equal to pi here, then we get this as sine of n pi. And what is the value of sine of n pi? Sine of n pi is 0, so this is 0, 0 into something is 0, so total term is 0. So then this is minus, again here cos term is there, so that means cos is non-zero, so we can write this as minus, and this minus we can write this as plus. If we put x is equal to pi, then we get this as pi minus 2 pi, we get this as minus pi. This is pi minus 2 pi, that's why this is minus pi. Into, again, if we put x is equal to pi, then we get this as cos of n pi. And value of cos of n pi is minus 1 raised to n. Then we can write this as minus 1 raised to n upon this is n square. So now this is very simple. Now next is that this is the term. If we put x is equal to pi here, then we get this as sine of n pi. If we put x is equal to pi, then this is sine of n pi, and value of sine of n pi is 0 according to the standard result. That's why this term is 0. Upper limit, now put the value of lower limit. Lower limit is 0. Friends, whenever we put the value of lower limit, either concentrate on sine term or x term. If x is equal to 0, so this term is 0, 0 into something is 0. Or second way, if we put x is equal to 0, then this is sine of 0, and value of sine of 0 is 0. So that's why this first term is 0. Now friends, here put x is equal to 1, this is cos term which may not be 0. So we can write this as minus minus, we can write this as plus. Then here x is equal to 0, then we get this as pi. Then if we put x is equal to 0, we get this as cos of 0, and value of cos of 0 is 1. We can write this as 1 upon n square. Minus, then the next term is plus. Again, if we put x is equal to 0 here, then we get this as sine of 0, and value of sine of 0 is 0. So we can write this as 0. So in this way, we can easily put the value of upper limit and lower limit for the given integration. Now after putting the value of upper and lower limit, next step is to simplify this term. So we can write this as minus pi, then minus 1 raised to n upon n square, then this is minus again pi upon n square. So we can easily take the term pi common from numerator minus pi. So we can write this as minus 2 pi upon this pi as it is. Again, this n square is also common. So we get this as minus 1 raised to n minus 1. So this pi term will get cancelled, and finally we will reach to the answer minus 2 upon n square. Then we may write this as plus 2, then this is 1 minus 1 raised to n. So if we multiply this minus to the inner side, then this minus become plus and plus become minus. So this is the value of our coefficient an. So now here we find the value of a0 and an. So these two coefficients we find. Now let's put this value in our equation number 1. This is our equation number 1. So substitute this value in equation 1. So after putting this value in equation 1, we get the required Fourier series expansion for the given function. So now here value of f of x. This side is f of x. Value of f of x is, this is x into pi minus x is equal to. Now put the value of a0 by 2. So value of a0 is pi square upon 3. We can write this as pi square upon 3 to the, we get this as 6 plus summation. So summation goes from n is equal to 1 to infinity. Now put the value of an. So value of an is 2 upon, this is n square, and then 1 minus 1 raised to n into, this is cos of n by x upon L. So we can write this as cos of n by x upon value of L is pi. So this pi will get cancelled, and finally we reach to the answer pi square upon 6 plus this is summation from n is equal to 1 to infinity 2 upon n square 1 minus 1 raised to n into, this is cos of nx. So in this way we can easily calculate the answer for the question for the half range cosine series. Now friends, this is the first example. So before proceeding to the second example, so in examination, so they may ask the question straightforward, find the half range cosine series. And most important thing about this half range cosine series is that here the value of interval is 0 to L. Now friends, this is the first example. Let's solve the second example. Now friends, let's take the second example. Second example is find half range cosine series for the function. Suppose f of x is equal to e raised to minus x in the interval. This interval is 0 to pi. So friends, here observe that straightforward question is there. So for find the half range cosine series. So that means here the value of interval 0 to 2l is defined as 0 to pi. So if we compare with the term 0 to l, if we compare these two interval, then we get the value of l is equal to pi. So now here straightforward question is there. Find the half range cosine series. Then definition of cosine series for half range is that f of x is equal to a naught by 2 plus summation a n cos of n by x upon l. Let's call this as equation number 1. To find out the Fourier series representation means find out the coefficient a naught and a n, which is given by these two results. Let's try for the first term, which is a naught, which is defined as 2 upon l integration 0 to l f of x dx. Now put the value of L and put the value of f of x. We write this as 2 upon value of L is pi. We can write this as integration 0 to pi. Then f of x, value of f of x is e raised to minus x into dx. If we find the integration of this term, then we get this as e raised to minus x upon minus 1. Its limit is 0 to pi, which is straightforward. Now take this minus sign common, we get this as minus 2 upon pi. Then we get this as e raised to minus x within the limit 0 to pi. Moreover, we get this as minus 2 upon pi. Then if we put the value of upper limit, then we get this as e raised to minus pi. If we put lower limit, then we get e raised to 0, which is 1. So that we can easily write this as 2 upon pi. If we take this minus sign to the inner side, then this minus become plus, then this is 1 minus e raised to minus pi. This is the value of our first coefficient, which is denoted by a naught. So value of a naught is 2 upon pi, 1 minus e raised to minus pi. So now after finding the first coefficient, let's try to find out the value of second coefficient. So for a substitution purpose, I will write the value of a naught here, so which is 2 upon pi, then this is 1 minus e raised to minus pi. So now friends, after finding the value of first coefficient, let's find out the value of second coefficient, which is denoted by an, and an is defined by this equation. So now let's first define an. So we can write an is equal to 2 upon l integration 0 to l, then this is f of x cos of n by x upon l into dx. This is according to the definition of an. Now put the value of l, we can write this as 2 upon pi integration 0 to pi, then value of f of x. Value of f of x is e raised to minus x into, this is cos of, this is pi upon pi will get cancelled. We may directly write the step, or one may write this as n pi x upon value of l is pi into dx. Moreover, we can write this as 2 upon pi integration 0 to pi e raised to minus x, then this is cos of nx dx. So friends, for calculating the integration of product of two terms, we cannot use the general rule for integration by parts, because for using the general rule for integration by parts, value of u in such a way that value of u must be in such a way that after finite number of steps, derivative of u will get vanish. So here it is not possible that after finite number of steps, a derivative of u will get vanish. So in this case, use another rule. So this formula is integration e raised to alpha x, then this is cos of beta x dx is equal to e raised to alpha x upon, this is alpha square plus beta square in bracket alpha time cos of beta x plus beta time sine of beta x. So this result is applicable here. Now if we compare these two terms, then here we get the value of alpha as minus 1 and that of beta is equal to n. Now apply this result, we get this as 2 upon pi, then in bracket integration, so we write this as e raised to minus x upon, this is minus 1 square, so this is minus 1 square plus n square, which is beta square. Then we get this as minus 1 into cos of beta, that means nx, plus beta, which is n, into sine of nx. So here limit for this term is 0 to pi. So we can easily find out the integration of this term with the help of this result. You must know this result for finding such type of integration. Now after finding this integration, our next target is to put the value of upper limit and lower limit. So here upper limit is pi. We can write this as e raised to minus pi upon this is 1 plus n square minus 1, each square is 1 square. Then we can write this as minus, then if we put x is equal to pi, then we get this as cos of n pi, and value of cos of n pi is minus 1 raised to n, so we can write this as minus 1 raised to n, plus again this value, if we put x is equal to pi, then this is sine of n pi, and value of sine of n pi is 0, that's why this term is 0. So this is the value of upper limit, 1 bracket, minus, put the value of lower limit. Here the value of lower limit is 0, so if we put x is equal to 0, then we get this as 1 upon 1 plus n square, then in bracket. So this is minus as it is. If we put x is equal to 0, then this angle becomes 0, so cos of 0, and value of cos of 0 is 1, so we can write this as 1. Then plus this is x is equal to 0, then we get this as a sine of 0, and value of sine of 0 is 0 according to the standard result. So we complete this bracket is over, and this bracket is over. Now after putting the value of upper limit and lower limit, just simplify this, we get this as 2 upon pi, then this is e raised to minus pi upon 1 plus n square, then this is minus 1 raised to n, this is the first term, then again this is minus 1 upon 1 plus this is n square, and this is minus become plus. Now friends, it is possible for us to take the term denominator 1 plus n square common, then we get this term as 2 upon pi into 1 plus n square common. Then after taking this common, this is positive term and this is a negative term, so we can write this as 1 minus 1 raised to n. This is 1 minus 1 raised to n into e raised to minus pi. So in this way we get the value of second coefficient, which is denoted by an. So after getting the value of second coefficient, put the value of a0 and an in equation number 1. So let's do the substitution, which is very simple. Only put the value of these two coefficient, we get the required Fourier series expansion of the given function. So value of f of x is e raised to minus x equal to. So now this is a0 by 2. So value of a0 is this much. So we can write this as 2 upon pi, then 1 minus e raised to minus pi, this whole thing divided by 2. So this 2 will get cancelled. Plus summation, this is n is equal to 1 to infinity. Then put the value of an. So we know the value of an, which is 2 upon pi in bracket 1 plus n square. Then again this is 1 minus 1 raised to n. 1 minus 1 raised to n e raised to minus pi. This is the term. Then again this is cos of n pi x upon, we can write this as cos of n pi x upon L, but value of L is pi, so we get this term in this way. So now once again, if we try to simplify this, then we get this as 1 minus e raised to minus pi upon pi, plus this is summation n is equal to 1 to infinity 2 upon pi 1 plus n square 1 minus 1 raised to n, then e raised to minus pi into this is cos of nx. In this way, we can easily solve the example which is based on half range cosine series. So this is our example number 2. Let's solve the third example. Now friends, let's solve the third example. So third example is find the half range of cosine series. So this word cosine is important. For the function f of x is equal to x minus 1 its square, where x is lies between 0 to 1. So now here straightforward half range cosine concept is there, and for this half range cosine concept interval is 0 to L. So given interval is 0 to 1, and here for half range cosine series interval is 0 to L. If we compare these two interval, then we get the value of L is equal to 1. Now this is the definition for half range cosine series. F of x is equal to a naught by 2 plus summation a n cos of n pi x upon L. Let's call this as equation number 1. Now to find out the Fourier series expansion means find out the coefficient a naught and a n. So here a naught is equal to 2 upon L integration 0 to L, then this is f of x dx. We can write this as 2 upon L integration 0 to L, but value of L is known to you, which is 1, so we can directly put L is equal to 1 here, and this is also L is equal to 1. Then put the value of f of x, which is x minus 1 its square into dx. Generally for finding the value of a naught, this result is applicable, so we can write this as 2, then this is x minus 1 its cube divided by 3 into derivative of this x minus 1 is 1. So now its limit is 0 to 1, so we can write this as 2 upon 3. If we put the value of upper limit, then this is 1 minus 1 is 0, minus lower limit x is equal to 0, so we can write this as minus 1 its cube, so we get this as 2 upon 3, then this is minus 1, then we get this as minus into minus 1, that means this is plus 1. So finally we will reach to the answer for a naught as 2 by 3. So this is the value of first coefficient. For substitution purpose, I will write this as a naught is equal to 2 upon 3 here. Now let's find out the second coefficient, and we know that this second coefficient is denoted by a n. So our next aim is to find out the value of a n. Now first define a n, so which is 2 upon L. According to this formula, we can write this as integration 0 to L, then f of x, this is cos of n pi x upon L into dx. So after writing formula for a n, put the value of L and f of x. So which is equal to 2 upon value of L is 1, we can write this as 2 upon 1 integration 0 to 1, value of f of x is x minus 1 its square into this is cos of n pi x upon 1 into dx. Now friends, this is the product of two term and its integration, so we can directly apply the generalized rule for integration by parts, which says that u v1 minus u dash, this is v2, so we can write this as v2 plus u double dash v3 and so on. We know the meaning of this generalized rule for integration by parts. Let's call this as the value of u, and this is the value of v. So this is our v. Now after doing this step, we can write this as 2, so we can write in better way. So this is 2, then do the integration of this term, so we write this as x minus 1 its square, then integration of cos is sine, so we can write this as sine of n pi x upon derivative of this n pi x with respect to x is n pi. First function integration of second minus derivative of this term is 2 into this is x minus 1. Again derivative of x minus 1 with respect to x is 1. So that's why we keep this term as it is. Again integration of this sine term. So we know that integration of sine is minus cos, we write this as minus cos of n pi x upon, again derivative of this n pi x is n pi, we can write this as n square pi square. Again plus sign, so plus derivative of this term. So this term is 2 into x minus 1, so we get this as 2x minus 2, so derivative is 2. So while taking derivative, don't consider this minus sign. This minus is because of the generalized rule. So now we can write this as 2 into integration of cos term. Integration of cos is sine, so this as it is sine, then sine of n pi x upon derivative of n pi x is n pi, so we get this as n cube pi cube, and its limit is here 0 to 1. So we can put the value of limit as 0 to 1. So after getting the integration of this term, so our next step is to put the value of limits. Now here upper limit is 1. So now whenever we put the value of limit, generally concentrate on sign term, because sign term is always 0. Generally sign term is 0. So if we put x is equal to 1, then we get this as sine of n pi, and value of sine of n pi is 0. This is the first reason, this term is 0. Or if we put x is equal to 1, then 1 minus 1 is 0. So 0 into something is 0. So this first term is 0. And this is minus, minus minus become plus, then this is 2. If we put x is equal to 1 again here, so this is 1 minus 1 0. So again the second term is also 0. Again for this term we get this term also 0, because if we put x is equal to 1, then we get this as sine of n pi, and value of sine of n pi is 0. So this is the value of upper limit, 1 bracket, minus put the value of lower limit, which is 0. So again concentrate on sine term. So if we put x is equal to 0, then we get this as sine of 0, and value of sine of 0 is 0. Then this is minus, minus minus become plus 2 times. If we put x is equal to 0 here, then this term is minus 1. Then after putting minus 1, if we put x is equal to 0, then this is sine of 0, this is cos of 0, and value of cos of 0 is 1. We write this as 1 upon n square pi square, plus this term, if we put x is equal to 0, then we get this as sine of 0, and sine of 0 is 0, so this term is also 0. In this way we can easily put the value of upper limit and lower limit. So if we simplify this, then we get this as 2 into this is minus 2, then this is minus become plus 2 upon this is n square pi square, and finally we write this as 4 upon n square pi square. So this is the value of our second coefficient, which is denoted by an. So after getting the value of second coefficient, put the value of a0 and an in our equation number 1. So let's do the substitution. This is very simple. Simply put the value of these two terms, we get the required answer. So now value of f of x is here x minus 1 its square is equal to a0. So a0 we mentioned here. So a0 is 2 by 3 upon 2. So we can write this as 2 upon 3 divided by 2. That means actually this 2 will get cancelled. Answer is 1 by 3. Plus we write this as summation n is equal to 1 to infinity. Then put the value of an. Value of an is, this is 4 upon n square pi square into cos of n by x upon. This is cos of n by x upon L, where the value of L is 1. So we can write this way. Or if we simplify this, then we get this as 1 upon 3 plus summation n is equal to 1 to infinity 4 upon n square pi square into cos of n by x. This is the third example which is related. Now friends, let's take the fourth example of this video lecture. So here question is find the half range cosine series. So cosine word is important. Whenever a cosine series is there, then for this cosine series interval is 0 to L. So here given interval is 0 to pi by 2 and pi by 2 to pi. That means total length of interval is 0 to pi. If we compare this with the interval 0 to L, then we get the value of L is equal to pi. So after getting this value L is equal to pi, now apply the concept of Fourier series definition. So definition of Fourier series is f of x is equal to a0 by 2 plus summation an cos of n pi x upon L. Let's call this as equation number 1. Now to find out the Fourier series means find out the Fourier coefficient a0 and an, which is defined by this result. Let's try for the first coefficient a0, which is 2 upon L integration 0 to L then f of x dx. So put the value of L, we write this as 2 upon pi integration 0 to pi, then this is f of x dx. But here friends, this f of x is splitted into the two parts. So let's divide this into the two parts. We write this as 2 upon pi, then first interval is 0 to pi by 2. So for 0 to pi by 2, value of f of x is x dx. plus second interval is this is pi by 2 to pi. We write this as pi by 2 to pi. Then value of this f of x is pi minus x into dx. Now just find out the integration of this first term and second term. We get next step as 1 upon pi for the first integration. So this is x. Integration of x is x square upon 2. Its limit is 0 to pi by 2 plus next term. This is pi minus x. We write this as pi x minus. This is x square upon 2 and its limit is pi by 2 to pi. So in this way we can easily find out the value of first and second integration, which is straightforward. Now after applying this integration, we can put the value of upper limit and lower limit. So for the first term, value of upper limit is pi by 2. Its square, that means we can write this as pi square upon 4, then this is 4 to the 8. Then minus lower limit is 0, because if we put x is equal to 0, 0 upon 2 means 0. Then plus we write this as upper limit is pi, so we write this as pi into pi. We get this as pi square minus this is pi square upon 2. This is the first term minus lower limit. So lower limit is pi by 2. So this is pi into pi. We get this as pi square upon 2 minus this is pi square upon this is 4. 4 to the 8. So we can write in this way. Now this bracket is over. Now after finding this, after putting the value of upper limit and lower limit, just simplify this. We get this as 2 upon pi. Then this is pi square upon 8 plus this is 2 common. Then this is 2 pi square minus pi square. We get this as pi square minus again here 8. Then 4 pi square minus pi square. That means this is 3 pi square. This is simple substitution. Then after putting this value, we can write this as 2 upon pi as it is, denominator common 8. Then we write this as pi square plus 4 pi square minus 3 pi square. So if we take the term 1 upon 8 common. So now we can easily write this as 2 upon pi. This is divided by 8. Then this is 4 plus 1, 5 minus 3. We can get this as 2 or pi square. So if we simplify this, then pi will get cancelled and 4 to the 8. So value of first coefficient a naught is pi by 2. So now let's write the value of a naught is equal to pi by 2 here for the further substitution. So in this way we calculate the value of first coefficient. Now our next aim is to find the value of second coefficient. So now friends, let's find out the second coefficient an, which is defined as 2 upon L according to this formula, integration 0 to L. Then this is f of x cos of n pi x upon L into dx. After writing this formula, put the value of L and f of x, where L is pi. We write this as 2 upon pi integration 0 to pi. But this integration limit 0 to pi is split into the two parts. So that's why write down this f of x as it is as a time being. Then we write this as cos of n pi x upon pi into dx. So this function f of x is split into the two parts. So we can write this as 2 upon pi. Let's split this into the two parts. First interval is 0 to upper limit is pi by 2, and for this value of f of x is x into this is cos of nx dx, plus next interval is pi by 2 to pi. We write this as pi by 2 to pi. Then put the value of upper limit, put the value of f of x, which is pi minus x into cos of nx dx. So in this way we put the value of f of x, which is splitted into the two parts. After putting this value of f of x, find out the integration of first term and second term. So friends, for finding the integration of these two terms, use generalized rule for integration by parts, which is mentioned according to this formula. So this is called as generalized rule for integration by parts. This rule plays very important role for finding such type of integration. Let's denote this first term as u and denote this second term as v. So apply separately generalized rule for integration by parts for first term and second term. So let's simplify for the first term. So this is 2 upon pi, then first term x, integration of cos. Integration of cos is sine, so we can write this as sine of nx upon derivative of nx is n, minus we write derivative of this term as 1, then integration of this term is minus cos of nx upon derivative of nx is n, so n into n we get this as n square, and its limit is 0 to pi by 2, so this is 0 to pi by 2. Let's apply the same generalized rule for integration by parts for the second term. Same rule. So let's call this as u and call this as v. So first term, which is pi minus x, then integration of cos. Integration of cos is sine, so we write this as sine of nx upon n. First function, integration of second, minus derivative of this term. So pi is constant, derivative of minus x is minus 1, so we write this as minus 1 into integration of sine, which is minus cos of nx upon, this is n square, and its limit is, so here pi by 2 to pi, we write this as pi by 2 to pi. Now this is over. Now after finding the integration of this term with the help of generalized rule for integration by parts, our next aim is to put the value of upper limit and lower limit. Here value of upper limit is pi by 2. So here if we put pi by 2, then this term is non-zero, because here we get this as sine n pi by 2. So this value is not known to us. So here this is sine of n pi and sine of 0. So this is not known to us. So as a time being, just put this value as it is. So this is pi by 2 into sine of n pi by 2 divided by n. So we can write this n here. So this is first term, minus minus plus. Again this is 1 upon n square into cos of n pi by 2. So this is the value of upper limit, one bracket, minus, put the value of lower limit. So lower limit is 0. If x is equal to 0, 0 into something is 0. So this first term is 0. Then this is minus, then this is minus minus plus. Again this is 1 upon n square. Then we know the value of this value of x is equal to 0, and we get this as sine of 0, and value of sine of cos of 0. So value of cos of 0 is 1. So we get this as 1. This is the value of lower limit. Now after upper limit and lower limit, apply the same concept for the second term. So here upper limit is pi. If we put pi here, then pi minus pi is 0. So this first term is 0. Again this is minus minus plus. Again this is minus. If we put x is equal to pi, then we get this as cos of n pi, and value of cos of n pi is minus 1 raised to n. We write this as minus 1 raised to n upon n square. This is upper limit, minus, put the value of lower limit. So lower limit is pi by 2. So we write this as pi minus, this is pi by 2. So this is one term into this is sine of n pi by 2. So this thing divided by 1 upon n. So this is 1 upon n. Then again this is minus minus plus. Again this is minus. Then this is 1 upon n square. Again if we put x is equal to pi by 2, then we get this as cos of n pi by 2. So now this limit is over, this bracket is over, again this bracket is also over. Now after putting the value of upper limit and lower limit, our next aim is to simplify this term. So we can write this as pi upon 2n into sine of n pi by 2. Then this is plus 1 upon n square into cos of n pi by 2. Then this is minus 1 upon n square. So this term as it is. Then this is minus minus 1 raised to n upon n square. Then this term is minus. So if we simplify this term, then this is pi minus pi by 2. We get this as pi by 2 into n. So this n we take here into this is sine of n pi by 2. Again minus this is 1 upon n square into cos of n pi by 2. So in this way, after putting the value of upper limit and lower limit, we simplify this term. Now let's check whether some term will get cancelled or it is possible for us to take some term common. Now this is plus term and this is minus term, so this term will get cancelled. So again, this term is also get cancelled. But here we get this is upper limit, this is minus and this is minus. So this minus minus become plus. By mistake we mentioned here minus, so actually this is plus because this is minus, and because this lower limit sign this become plus. So we write this as 2 upon pi. Then this term and this term is same. We write this as 2 upon n square into cos of n pi by 2 minus 1 upon n square minus 1 raised to n upon n square. So in this way we get the value of second coefficient an, or it may possible for us to take the term n square common. So we get this as 2 upon pi n square, then in bracket we get this as 2 times cos of n pi by 2 minus 1 minus 1 raised to n. So this is the value of our second coefficient. So after getting the value of this second coefficient, put all this value in equation number 1. So after putting this value in equation 1, we get equation 1 as, this is simple thing, just put the value of a0 and an. So this side is f of x, value of f of x is split into the two parts. So we write this f of x as it is, it equal to a0 by 2. So value of a0 is pi by 2. So we can directly write this as pi by 4 plus summation. This is n is equal to 1 to infinity. Then put the value of an. So value of an is defined as 2 upon pi n square. Then in bracket this is 2 times cos of n pi by 2. So this is the value 2 upon pi n square. 2 times cos of n pi by 2, and this is minus 1 minus, again this is minus 1 raised to n. This is the value of an into, this is cos of n pi x upon l. We can write this as cos of n. Value of l is pi will get cancelled. We get this as cos of nx. So friends, in this way we can easily solve the example which is based on the half range cosine series. Here we solve 4 example for your understanding purpose. Now let's take some example for your practice purpose. Now friends, time is to test your knowledge. So for your exercise purpose, total 7 examples are given. So try to solve this example based on the knowledge which is provided in this video lecture. Now here our first example is find half range cosine series. For all this example, find the cosine series. The first example is f of x is equal to x sin x, interval is 0 to pi. So this is the answer. A second example is f of x is equal to x, interval is 0 to 2, or sometime here for this term x, interval may be 0 to pi also. So this is one of the example, or we may put the interval as 0 and pi. You will get another example. This is the answer related to the second question. Then third question is f of x is equal to e raised to x, interval is 0 to 1. This is the answer. Now this is the fourth example. So here we can write this as 1 upon 2 pi minus x into sin x. Let's solve this example. Then fifth example is f of x is 1 and x. This is the value of a0 and this is the value of an. Then f of x is equal to 1 and minus 1. Again interval is 0 to pi. a0 and an is given. Last example is f of x is equal to x minus x square. Interval is 0 to 1. This is the value of a0 and an. So friends, for all these 7 example, find the half range cosine series. So for this half range cosine series, interval is 0 to L. So in this video lecture, friends, we learn how to find the half range cosine series. In our next video lecture, we are learning how to find the value of half range sine series. So my request to all of you is that please solve all these 7 example as a practice, then you will get idea about this half range cosine series. This concept is very important for your exam point of view. Now friends, we stop here. I hope you like this video lecture. So thanks to one and all for watching this video lecture. Thank you.